Hi class. In this video here, we're going to go into section 7.2, and it's titled The Infinitely Detailed Beauty of Fractals, or How to Create Works of Infinite Intricacy Through Repeated Processes. All right, so what's going on in this section? So some artists are renowned for their attention to detail, producing pictures that are incredibly intricate. Yet only within the realm of mathematics can images be created that are literally infinitely intricate. What does infinitely detailed mean? Could such an image be drawn with the finest pen point? So, of course not, because we're talking about infinity. But it is possible to describe such images so precisely that for any point on our canvas, we can determine whether that point is in the design or not. These images can be drawn to any degree of detail that our finest printers can muster. But the totality of the intricacy is fully present only in our mind's eyes. Every power of magnification reveals yet further detail. So in some cases, we will understand the image so well that we can literally draw an enlarged version of the tiniest parts, magnified a million, a billion, or even a trillion times. Other images reveal, unthought of variations and surprises at every increases level of magnifications. Okay, so these mysterious images give us new vistas to discover as we explore them in an ever-increasing depth, yet continue to hold deeper secrets for others to uncover later. And so we're going to begin with super simple concepts, okay? So these images of the mind are created by following a pattern. So what we're going to that is repeated over and over and over forever. And that's what we're going to do in this section. We're just going to look at art or images that are created by repeating, listen how I say this, repeating the same pattern over and over again. So like barbers and hairstylists make us all familiar with this kind of process when they use two mirrors to enable us to see the back of our heads. And we see the hairdo after neatly cut hairdo receding into the distance. Feedback loops of video images generated by pointing a video camera at the screen of a monitor displayed the video feed are another example. So feedback processes create great pictures of infinite detail and intrigue. So what we're going to do here is we're going to explore infinite, intricate images by looking at some very specific examples. So this section, when you read the section on your own, has a lot of different examples. So in my video lecture here, okay, I'm not going to cover every example. I'm just going to focus in detail on the Sierpinski triangle and collages, okay? So you'll need to read the entire section for each example. This is important, especially when you go to do your mindscapes and the assignment for the week, okay? All right, so the basic concept here is this idea of self-similarity. So a key concept of our study of these fractals is self-similarity. That is the characteristic of looking the same or similar to itself under increasing magnification. Okay, so an object that has this distinct self-similarity feature is referred to as a fractal. So basically when I zoom in, it still looks the same. That's what's going on here. Okay. So coastline and broccoli are examples of this. Like in broccoli, if you look at a big piece of broccoli and you zoom in on just this part, it looks like this. And then when you zoom in on the top here, it looks like this. They're looking similar to each other as you zoom in. Coastlines too. Like if you look at the map of Europe here, right? You zoom in, coastlines are all it's looking the same, same type of pattern. So we'll see some purely geometrical fractals that are so eerily resemble natural objects that we will have to wonder whether the physical processes that produce self-similarities in nature might be similar to the iterative process that produce self-similarities in geometric examples. Okay. What exactly is the Sierpinski triangle? Well, there was this mathematician named Wojciech Sierpinski, okay, first described his fractal triangle in the year 1916, a long time ago. So what we do is we start with a filled-in triangle, and we replace it with a triangle with the upside-down middle triangle removed, as illustrated here. Okay, so basically you're just replacing it. You're removing a middle triangle here. This process now leaves three filled-in triangles. Okay, each is a smaller version of the original triangle. We have therefore established a process of replacing a filled-in triangle with three smaller triangles. So what I'm going to do in this triangle here is I'm going to do the same exact thing. And then in this one. So when I do that, this is what happens. All right. So we can take the result of the first replacement process and replace each of the three smaller triangles with three yet smaller triangles. All right. When we do that, look at how many triangles we get. 1, 2, 3, 4, 5, 6, 7, 8, 9. When we do that now to each of the 9 filled in triangles present, we do the same thing, okay? And we can continue doing this on and on and on and on forever, okay? So replacing the triangles with the pattern. All right, so notice that the resulting object, known as the Sierpinski triangle, looks exactly like any one of the 3 subtriangles that it comprises it, except for scaling, okay? Like right here. It also looks exactly like any of the 9 filled in subtriangles on the next stage, and so on. And the construction guarantees this self-similarity because the process of replacement is identical for each subtriangle as it is for the whole triangle. So you're just repeating the pattern deeper and deeper and deeper and deeper and deeper into the triangle. Now we're going to take that concept and talk about making a collage. And so what I have here is pictures of the authors of the textbook, right? So what you see in here is I take a picture, and then I take those 3 pictures, that picture, and I make a collage out of it, all right? I take this one picture and replace it with 3 all in different locations. And then I take the pattern that I just have, and I do it again, the same thing. Okay, I put this picture here. I complete the pattern 1, 2, 3, and then you can see what I can do is I can keep doing this and doing this and doing this. And so these are instructions for creating repeated image collages. So you're going to start with the picture. You're going to make some number of copies, each reduced by a specific amount. Like if you look here, these images were reduced from this size. Position each reduced picture on a page in a specified location, creating a new picture on the page, right here. And then you're going to start with the resulting picture and return to the first step, repeating the cycle forever. So like what I did here is, now that I have this, I'm going to repeat this cycle here. And then I'm going to repeat this again and again and again. All right, so let me walk through it. Start with the picture. Then you're going to make a specified number of copies. Here's what we're going to do. We're going to pick 3. And you could reduce the pictures by any size, okay? So for example, this is 5 centimeters. I'm going to reduce it down to 2. And then I'm going to reduce another one down to 1 centimeter. And then 1.5 centimeters, okay? So I'm reducing the size, okay? Then what I'm going to do is I'm going to position them, my 3 new my 3 new pictures, anywhere on a piece of paper, okay? So to create a particular image, okay? So you can rotate them, whatever you want. Then I'm going to do the same thing. This new picture is then used to start the whole process again. I'm going to take this picture, reduce it in size, okay? Just like I did before. And then what I'm going to do is I'm going to position them exactly like I did before. Okay, this is what I did. And then I'm going to take this picture and then I'm going to repeat through the whole process. And what you could see is the pattern stays the same, okay? But the pictures keep getting smaller and smaller and smaller, but you still have the same overall pattern. And so what we're going to do now is we're going to talk about creating the Sierpinski triangle using the collage method. So when we created the Sierpinski triangle using the collage method, we started with an equilateral triangle and we made 3 smaller copies, right? The smaller copies were each half as tall and half as wide. Okay, so that's how we reduced it. And we placed them into 3 positions on the page. So let's follow these exact same instructions, but this time let's start with a square instead of a triangle, okay? Notice that the first figure does not look too much like the Sierpinski triangle. However, let's take that image and apply the collage making instructions, okay? So let's take the resulting picture and make 3 reduced copies. So we had our picture. Now we make 3 reduced copies, all right, and place them in the specified positions again. Now we have what looks like a block-like Sierpinski triangle. After several more repetitions of the process, notice how the images are becoming more like the Sierpinski triangle. If we look very closely at the last image, you'll see them on the left here, we will still see tiny squares making up the image. However, the impression is now of triangles, not squares, okay? When you continue this on forever, all right, the resulting image is exactly the Sierpinski triangle. So what basically happens is the image gets so fine that it's just triangles, okay? And it's true that you can do this with any image, okay? Like if you look, we start with circles, and then we apply the collage making method. eventually it just starts to look like triangles. Look at this shape, okay? If you apply this collage making, it's starting to look exactly like triangles. Okay, so it turns out you can pick any image, and if you go through this reiterative process enough, it's just going to turn into a Sierpinski triangle. All right, let's just do one mindscape to end this, okay? And this is sticking with the Sierpinski triangle. So at stage 0, the Sierpinski triangle consists of a single filled-in triangle, okay? At stage 1, right here, there are 3 smaller filled-in triangles. How many filled-in triangles are there at stage 2? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we started with 1, 3, 9. How many are at stage 3? 27. Could you guess how many there would be at stage 4? Okay. Notice what we're doing. We're going by factors of 3. 1, 3, 9, 27. This is 3. This is 3 squared. This is 3 cubed. Okay. So this at stage 4, if you were to count all those triangles, there'd be 81 of them. Okay. And so how many stages will there be at the nth stage? Okay. So look what I did. 3, this is 3 to the first power. 9, this is 3 to the second power. 27 triangles here, that is 3 to the third power. 81 triangles here, that is 3 to the fourth power. So whatever stage it is, it would just be 3 to the nth power would signify how many triangles there are. So at the 5th stage, how many triangles there would be if you were to repeat this process again? There'd be 3 to the 5th power. At the 6th stage, there would be 3 to the 6th, and so on. All right, class, we'll continue our study of fractals as we move into the next section. But as always, if you have any questions, please let me know.